let's go to page 89. And this is chapter 7, so let's start with 7.1. So this section is about factorization. Factorization can be used to evaluate things, especially if you're not allowed to use calculator, or if the number is very long that you're unable to display on the calculator display. And so let's go straight to, so for example, that if you want to evaluate 0.00002 square minus 99998 square. So normally you will square this and you square that, you subtract. Okay, but the problem is, again, the numbers can be long. Okay, so what you can do is use the technique of factoring. So remember the difference of square, x squared minus a squared. This is equal to x plus a, x minus a. So if you apply that, okay, then this becomes 10002 plus 99998 times 10002 minus 99998. Okay, and so when you add, this will give you 2, 1, 2, 3, 4. Okay, so 0. Go 1, 2, 3, 4. Yeah. Okay. So just have to count up the digits. So this plus will give you that. This minus that will give you 4, and so the answer will be just equal to 800,000. Okay. So you can see that's much quicker if you can use the factoring. And now there are the several special factoring that you need to know, like a squared minus b squared. This is equal to a plus b, a minus b. So this one is kind of obvious. The second one, the sum of the square, is not as obvious. This is kind of the reverse. So a squared plus b squared. This is equal to a plus b squared minus 2ab. Okay, so if you were to move this over, then it's more obvious. But when you do it in this way, it's not as obvious. Okay. So again, if you move this term over here, then if you have this equal to this plus, it's obvious. And you also need to know the difference of cube. So you have a cubed minus b cubed. And the easy way to memorize this is you put a parenthesis right below it and get a bigger group. So go and just take the cube root of that. So it would be a minus b. And then when you have to multiply, so again, notice there's no middle term. But to get a cubed, you need to have an a squared, right? A times a squared give you a cubed. Negative b times positive b squared will give you b cubed. But when you distribute, you're going to get another middle term. So to cancel out the middle term, you have to take the opposite of that. So it will be plus ab. Okay? So again, by plus ab, when you distribute, it will cancel all the middle term to get that. So number 4, again, to factor a cubed plus b cubed. Okay, so again, just take the cube root. So you're going to get a plus b. And then from here, you need to have an a squared, because a times a squared give you a cubed. And you need to have a b squared, because b times b squared give you b cubed. But again, when you distribute, when using the distribution, you're going to get a lot of middle term. To cancel the middle term, you have to take opposite of that. So it'll be minus ab. And that way, when you distribute, the middle term get all canceled out, and you end up with that. Okay, so let's go over examples. Now, let's look at number 2 again. So, when you have an x squared plus y squared, this is equal to x plus y squared minus 2xy. But this is not useful unless you can factor in more. And so normally when you have square, this is it's not helpful, but when you have the fourth power, okay, it will become helpful. Okay, so let's go to, what I mean by that is when you have x to the 4 plus y to the 4, this will equal to x squared plus y squared minus 2x squared y squared. And so now you have the difference of square, okay? And so you're going to get x squared plus y squared plus, in this case, it will give you square root of xy, and you're going to get x squared plus y squared minus square root of xy. Okay, so in this case, you will have able to do that. Okay? But this one is not as helpful because you're going to end up with square root of x and square root of y. Okay, so let's go to example 7-1. Well, 7-1. It says show that a cubed minus b cubed is equal to a minus b, a squared plus ab plus b cubed. So you want to prove the one we did earlier, prove this one. Again, to prove that, all you have to do is distribute, so multiply everything out. So a cubed minus b cubed. Again, when you're doing the proof, you keep one side the same and you go and just manipulate the other side. So you multiply, you're going to get a cubed plus a squared b plus a b squared minus a squared b minus a b squared minus b cubed. Okay. And so this term a squared b and this cancel out, and this term and this cancel out. So you got a cubed minus b cubed equal to a cubed minus b cubed. So check. Okay, so that's how you prove that. Okay, let's go to example 2. Example 7-2. So if you have 1 over a plus c equal to 1 over a plus 1 over c, you're looking for a over c cubed. So when you have a variable in the denominator, it's kind of hard to work. So go and multiply everything by common denominator. So multiply by ac, a plus c, ac, a plus c, ac, a plus c. And then things get cancelled out, so you got ac equal to ac plus c squared, and this cancel out, so plus a squared plus ac. And go ahead and move things around. So this cancel out. So you end up with a squared plus ac plus c squared equal to 0. And again, remember this is part of the cube, okay? So if you were to factor, if you multiply by a minus c on both sides, okay, so if you multiply by a minus c on both sides, this becomes a cubed minus c cubed equal to 0. And you move this over, so you got a cubed equal to c cubed. Then you divide, so a cubed, so you plus c cubed on both sides. Then you divide, so you got a cubed over c cubed equal to 1. And therefore, a over c cubed equal to 1. Okay. Okay, let's go to example 7-3. You want to find the sum of 1 over 3 plus 2 square root of 2 plus 1 over 2 square root of 2 plus square root of 7 plus 1 over square root of 7 plus square root of 6 plus 1 over square root of 6 plus square root of 5 plus 1 over square root of 5 plus 2 plus 1 over 2 plus square root of 3. So when you have a long expression to evaluate, right away you know there had to be a trick, okay? And the thing to do is by pattern. So if you put anything into the square root, so this is 1 over square root of 9 plus square root of 8 plus 1 over square root of 8 plus square root of 7 plus 1 over square root of 7 plus square root of 6 plus 1 over square root of 6 plus square root of 5 plus 1 over square root of 5 plus square root of 4 plus 1 over square root of 4 plus square root of 3. Okay, then after you're going to evaluate each one. Okay, so if you do this one individually, you're going to get 1 over square root of 9 plus square root of 8 multiplied by the conjugate. Okay, and it's going to give you, so this is going to give you 9 minus 8, and on the top you're going to get square root of 9 minus square root of 8. Okay, and so this will equal to square root of 9 minus square root of 8. Okay, so again multiply conjugate. So this you're going to end up with square root of 9 minus square root of 8 from this part over here. This one you're going to get plus square root of 8 minus square root of 7. This one's going to be square root of 7 minus square root of 6. This one's going to be square root of 6 minus square root of 5. This one's going to be square root of 5 minus square root of 4. This one is going to be square root of 4 minus square root of 3. Okay. And you can see that all these get cancelled out. So all you have is square root of 9 minus square root of 3. So answer would be 3 minus square root of 3. Okay, so notice the pattern and know the trick.